Good afternoon, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. A little bit about our group. We meet every month. The meetings are free of charge and open to the public. We cover any and all topics related to .NET, and you can find meeting information posted on meetup.com at the link listed below. I'd like to give a big thank you to our sponsors, Tech Systems, that have supported the meeting space back in the days before COVID, and they will be there for us once we resume in person again. The pizza and the drinks, courtesy of Inito, again, back in the good old days before COVID. And we'd also like to thank PostSharp and DevExpress for providing prizes that will be handed out once we get the eval forms. Also like to thank NIS Technologies for providing web hosting services. In addition, we'd like to welcome to our sponsorship, Manning Publishing, and we'd like to thank them for the special offer they're providing the group. They are providing a 35% discount at manning.com, and you have the discount code displayed there, NTPCLEC21 ! And I will post that in the chat window in just a little bit. Some general information before we get started. Please keep in mind participation is encouraged, and the only stupid question is the one not asked. So chances are, if you have a question in mind and you're kind of hesitant, don't hesitate. Someone else more than likely has that same question in mind. Also, feel free to jump in verbally to comment or to ask questions, but kindly ask you to mute your microphones when not speaking, just to avoid any background noise. So we like to keep it as casual as possible, but at the same time organized enough to let the speaker go through all the presentation slides and the demo code. And as you had heard earlier, the presentation will be recorded and posted on YouTube, and the link has been shared with you over in the chat window. And then likewise, I will share it again towards the end of the presentation. For tonight's feature presentation, we have Hasan Savran, and he'll be talking about graph tables and what do they bring to the table. No pun intended, right, Hasan?
That's right.
Right. So Hasan is a BI manager for Progressive Insurance. He's also certified with MCSD, and he's a Microsoft MVP in the data platform. He's an active speaker at various conferences, code camps, and user groups. And he's a member of the HTML5 and WebAssembly W3C groups. And he blogs actively over at hsavran.blogspot.com. Overall, he's a great speaker, a great mentor, and looking forward to his presentation. So with that, let me turn it over to Hasan, and I will make you presenter. And it's all yours, Hasan.
All right. Thanks for having me today. Let me share my screen here quickly. Can you see my screen?
Yep.
All right. Well, thanks everybody for coming to my session today, and thanks Sam, having me today. I'm going to speak about the graph database. Well, databases, I guess, because they are not really, special for SQL Server. They have been out there for some time, and SQL Server decided to include them in 2017 and later versions. So in this talk, really, I'm going to try to explain to you like when to use them, how to use them, and give maybe some kind of history to you, like where they are coming from, and I will try to actually show you how to create them, how to query them. And in 2019, there are some updates came up to the SQL Server. So I will show them to you too, and we will end the session with many demos, and I will show you actually how to do it by using the Management Studio. So that is the plan. So let me actually continue here. As Sam introduced me, I'm a data platform MVP. I'm currently, working in Cleveland, but I live like right between the Akron and Canton area. And currently I work for Progressive Insurance as a business intelligence manager. I have a great experience with web development and data. So if you will have any kind of questions that you might not ask today, please reach me from the LinkedIn or Twitter. I will be more than happy to answer and try to help you with any of the questions you might have. And yeah, check out my blog too. I have all kind of information out there. Mostly lately I write about the Cosmos DB and SQL Server, But you will find some interesting stuff about the front end and C# too. So whatever I know, I try to share it out there. So let's actually jump into the presentation. Graph database tables. Well, we live in a connected world, and with AI is actually going in and it's everywhere right now. The things are changing really quickly. So if we actually maybe go back 10 to 20 years and look at some of the big changes happening in our life, the first one I guess we can give you is the entertainment. There used to be a company name out there, Blockbuster. Now it's nowhere. Netflix just took its place. We have all kind of evolution happen with the cars, especially. Well, now cars can actually drive themselves, and that changes affecting the insurance companies. How are you going to write a policy if the car is going to make an accident and well, the driver wasn't driving it? So, and also we have like a company named Carvana. There's like vending machines. You can actually buy a car by just using tokens, which is crazy. We have evolution in IoT. We have a lot of devices, more than 30 billion IoT devices on Earth, and pushing, generating data constantly. So whenever you create a data model for that, you kind of need to be careful because the IoT devices changes too, and the data you might create this year might be totally different than next year, and data modeling becomes, I guess, a challenge. Evolution in healthcare. Before the insurance, I was actually in healthcare, and I was actually there. So I was in one company out there, and we were actually changing from paper chart to electronic chart. Nobody was happy. Nurses were not happy. Doctors were not happy, and nobody likes changes at the end. So I don't know how many times people tried to throw me charts, paper charts, because they were not happy with the system. It wasn't my fault, but hey. So when business changes like that, or when a change becomes to in business life, usually the first thing changes is the data. And you cannot just throw all the data you had before. It's much easier if you can actually create relations or the new domains and be able to join to your older data, but that might be a challenge, especially in the relational databases. In relational databases, really do not adapt well to the changes. They work best for the problems that are well defined at the outset. So creating data models, especially if you are using the relational databases, can be a challenge, especially in these days, because you really need to think about the feature whenever you are creating the data model. What other tables I might need to kind of include later, or what other relations might come into this. So you kind of need to keep options open. So, and also another challenge with the relational databases is you cannot create many-to-many relations between two tables. You have to create a whole different table, which called junction tables, and you have to put the primary key and foreign key into that table. So that's how you actually create the many-to-many relation between two tables. Actually, it becomes three tables. So graph database tables actually giving some solutions to that. And as I said before, graph database tables are not really new, but I think that was very smart of Microsoft adding that to relational database, which is a SQL server they have. Actually, it helps with all the problems I just actually counted here with the relational database engine. So I guess first question usually I get is, who's using graph database tables? And for that, I have really, I guess, three main options here, or the most common ones. The first option here is the suggestion engines, and suggestion engines are everywhere. So if I give you an example, the first one will be probably Amazon. So if you go to the Amazon, let's say you want to learn a new technology. Let's say you want to learn Kubernetes, right? Because everybody is learning it and it's a feature just like anything else. So you say, well, I'm going to go and look for some, books so I can actually learn it. So you look at the books, many of them comes up, and you just pick one book and a product page comes up. And usually it has some pictures of it, and it has a price. When you scroll down, more information about the book, who's the vendor, who's the writer. When you start to scroll down though, you are going to actually the page becomes more interesting, because then Amazon actually starts to suggest you stuff, like they are saying, for example, person who's buying this also buying this product. So if you think about that, and if you try to actually create this in a relational database, that's a big challenge, because now a product page should come to be rendered 2 to 3 seconds. That gives you maybe like 1 second to actually be done with the data repository, so you will go and have time to render the data. So in 1 second, you are going to get all this information about the product, and also, I mean, this is not the only kind of suggestion Amazon has, but in the meantime, you need to figure out, okay, the people who's buying this product also buying what other products? How many joins are you going to have up there? So probably that's not going to be a dynamic way in relational database tables. The best thing probably you can do is maybe you will have an ETL SSIS package, which maybe runs every 30 minutes and figures this out and put them in a table so you can read from there. That's an option, but still, it's not dynamic, it's not real time. So graph database tables actually gives you a great option to give some kind of function like that, very simple for the users. Next one, we have the government. That works actually with the healthcare too. So let's say, we have maybe an agent in FBI or CIA, and they have your social security number, and they just type it. When they type it, they're going to have all this information coming from many agencies of government, and you have records in many areas. So as a user, what you want is you want to see that person one, and after that, when you click on it, you're going to see all the data kind of organized in one section. You don't want to see the same person many times on your screen. So that calls mostly the master data management systems. So you have the data, but you display it once, and you don't multiply the data in the database. Graph database works for that, great. Third option is the social media, and the best example for social media probably Facebook. So when you go to Facebook, what do? Usually you kind of like things, right? So you are the user, that's the entity, and you like picture, you like a post, you like a page, you like whatever actual Facebook has. If you think about it, you have two entities, and the relation is always same. So there, we hope there was like a way that you can actually create that dynamically by using the same relation type, and you can just join all the entities. In relational database tables, you cannot do that. You have a primary key, you have a foreign key, that's it. So those are the options, and I'm going to actually show you in each systems how to use the graph database tables in a minute. But before that, usually people actually talk about the other options in SQL Server, which we have another option, especially for the hierarchical data. When it comes to the hierarchical data, we have a data type named hierarchy ID, which was introduced, I believe, in 2008. So it has been out there for a long time. It is mostly for the highly structured data. And if I give you an example, for example, the HR org, for example, you have a CEO, under CEO, you have all the layers going on. And that really fits perfectly for hierarchy ID. You can have only one parent and multiple children under that. So it's always the one-to-many relation. So if you are a manager, you cannot have, I guess, two managers on top of you. It has to be only one. In graph database tables, there's no kind of limitations like that. You can create many-to-many relationships very easily. And like hierarchy ID, you need the CEO. CEO becomes I guess, the parent of everybody. So you need the root. In graph database tables, you don't need a root for like that. Both are indexable. The hierarchy ID probably is not, as I said before, it has been out there for 2008, and not many people uses it. And I'm guessing the biggest, I guess, reason for that is because it's a CLR data type. So you have to use the CLR functions to find data. So whenever you actually talk about this is a CLR data type, then DBAs really just says no, really. They don't want to kind of hear about it. So probably that's one of the main reasons that we don't really see the hierarchy ID that much in solutions. But it's indexable, and graph database is indexable too. To find the data in the graph database tables, we are going to use the match clause, which is going to go in the where filter, which we will cover that. And well, graph database tables are introduced in 2017. Now, let's actually look at what graph database tables looks like. So we have two types of tables. The first one is the node tables, and that one keeps entity data. What is entity? It can be person, it can be order, it can be vendor, some kind of entity. And each node table has a special column named node ID. Node ID is the identity of each entity. It's auto-populated, and if you will actually say select all from any node tables, you will see the node ID out there, and the value of node ID is JSON document. You won't have any business with it. You won't change the value of it. System actually uses that to find data whenever you use the graph database tables. Rather than that, node ID, you can have any type of columns in node tables. If SQL Server supports it, you can put on it. Also, we have a different table type, which is the edge tables. Edge tables keeps relations information about the entities. That makes the relations are, the first-class citizen in the graph database tables. So just like the node table, we have an identity column named edge ID, and it's a JSON document. If you will look at it, it's a JSON document in it. Just like the node ID, you cannot change it. It's just there for the system use. And very interesting part of the edge tables is you can have any type of columns in it. So if you want to kind of have like any kind of metadata about the relations you are creating between entities, you can put them in the edge tables rather than, you're not stuck with one big table. For example, you are creating some kind of information, you are saying this person, or you have a product like this product, you can have other columns out there say that when you actually create this relation, who created this relation, you can put all of them in the edge table. Rather than that, we have two more special columns here. One is the from ID, and the second one is the to ID. So those are probably the most important ones in the edge tables. Those are the node IDs coming from the other entity tables, and you are creating a relation between those two node IDs. So if I give you an example for that, let's say we have a users table, and let's say we are going to say that we have a user named Alec and another user named Anna, and we are going to say Alec likes Anna. So what are you going to do in here? That you have the users table, you're going to create an edge table, you can, I guess, call it like. So you're going to get Alec's node ID and put in the from ID, and you're going to take Anna's node ID, put in the to ID in the same row. That's going to make Alec likes Anna. So directions are important in edge table, which means that, yeah, Alec likes Anna, but it doesn't mean that Anna likes Alec back. If you want to say the same thing, you need to create another row for that. You're going to say, node ID of Anna, that's going to go to from ID, and Alec's node ID is going to go to to ID. So the directions are important. Relations cannot be updated. Any other metadata columns that you have, for example, if you have a column name, whenever you create this created date, you can update that, but you cannot update from ID, or you cannot update it to ID. Main reason for that is if you really think about it, you have a table named like, and you are saying Alec likes Anna, right? How are you going to update that? Alec likes Anna or not? If Alec doesn't like it, you just remove that from the table, really. So there's no update in the from ID or to ID. Now, let's actually look at how to create graph database tables. The first one is the node table. As you can see, we are still using the create syntax here, and I'm putting all kind of data types, whatever SQL Server supports, we can put it in. And to make that node table, all we are here doing is we are adding as node here. That makes this table a node table. Edge table, you don't need to have any columns in it because you are going to have edge ID, from ID, to ID is going to get populated and created automatically when you actually call the as edge here. But just an example, I'm adding another column here, create a date, and that's a computed column. Every time I insert something here, I'm going to get the date, so I will know when the relations are getting created. So by just putting the as edge, that's going to make this table a relation table. When I run this two queries, you are going to actually see them under the graph tables directory, and we will have the alike product and products table. I'm not sure if you can see it, but this one looks like there are like two dots here. It almost looks like glasses. That means this is a relation table, and we have one solid dot here. That means that that's a node table. So we have the tables. How about inserting data in these tables? Now, for the node tables, which actually keeps all the entities, there's really nothing different. We are still using the insert statement here. Just list the column names and values, and that's it really. We are not specifying node ID. Node ID is getting auto-populated, and really nothing is different in the node tables when it comes to the inserting data. Edge tables can be a little bit different. So we have to get the from ID and to ID values from other tables. So in here, I am, let's say we have a table name alike product, and I am getting the product IDs 1 node ID and product 2 node ID. So what I'm really doing here is I am saying product 1 is like product 2. And I'm passing the get data. I don't really need to, but if you have any other columns here, you can actually add them here. So that's going to actually create a relation between two entities. When it comes to the updating, update works exactly the same for the node tables, update statement. And edge tables, you can update any columns that you created rather than from ID and to ID. You cannot update them for when it comes to the updating. How about selecting the data? Now, if I'm going to say select all from node tables and edge tables, that's what you're going to actually see. As you can see, we have the node ID, there's a JSON document in it, and everything else is normal here. And we have the edge tables. As you can see, we have edge ID, from ID, to ID, and other columns you might have. So when you look at it like that, it really doesn't kind of make sense, and it's not going to be easy to read. So you need kind of like a special way to find what you are looking for here. To find the data, you are going to use a new syntax. It's a match clause, and you are going to use that in where filter. So match clause actually accepts graph search pattern. It sounds complex, but it's not really. So by putting that pattern, you are really specifying what you are looking for. So pattern needs to go at least from one entity to other entity by using one relation table. And you are going to use the arrow character to specify which direction you are looking for when you look at the data. And we are going to use the parentheses to actually remark the relation tables. That's going to make the things, I guess, easier to read because, you know, probably you are going to use alias to whenever you are writing the this graph search pattern. So it will be easier to figure out which alias is for, you know, it's a node table or it's a relation table. If I'm going to give you one example here, for example, we have a products table, wish table, and users table. As you might guess, products is an entity table, users is an entity table, and wished is a relation table. So my match clause is actually going from users table to products table by using the wished relation table. This is going to give me all users wish list. But I don't want all users. I want only user ID 1. So you can actually add more filters on top of that if you like. In this case, I'm looking on the user ID 1. So when I run that, that's going to give me all the columns that I specify here. And that's how you are going to actually find the data in graph database tables. So if I give you more, I guess, examples for match, let's actually try to see for other industries how they can use this. The first example was Amazon, right? So you were looking for a book and you scroll down and Amazon was actually suggesting that I have some other products like the one that you are looking at. So to do that, we have a product table and we have a like relation table we create. So let's say that, for example, in this page, we are looking Kindle Fire here, right? And we have iPad and Samsung Galaxy in our store too. So we want to, suggest that to the user at the when they scroll down. So to do that, we know the product ID. Let's say this is the one, and we are going to use the alike products to actually give a query. So our query is going to just look like that. So this is going to give me all the products like product ID 1. As you can see, it's pretty simple query, and it's going to make really, I guess, complex job easy for us to actually display the data in the website. Second one is healthcare. So one of the biggest problem in healthcare is, right now we have the HL7 and everything is, all the data is getting shared. So your hospital might be getting data from other hospitals, labs, stat cares, and you kind of need to get that data. You have to match and merge the data. So whenever a doctor actually goes to the computer and look at that person's information, all the data should be under one page. You shouldn't have data saying that, oh, this person is coming from this hospital. Here you have to look at it, or stat cares are here. So it's much easier to kind of put everything in one place. So the problem with that is, well, you kind of need to have enough information to make a match and merge, especially the patient information, because you don't want to, I guess, merge wrong people. That can be tricky. If you have, for example, social security number, that makes things, I guess, easier. But sometimes we might not have that. So you might need to look at the date of birth, you might need to look names, you may need to look at address and all kind of other stuff. So whenever you are doing that, you can really use the graph database tables for that. For example, we might have a patient named Michael Miller. That looks like that's what we register him. But in the meantime, we might have records coming up from the same people. Maybe some of the labs were registered as Mike Miller, and maybe he was in another hospital and they use his middle name, Michael T. Miller. So you might want to kind of use the graph database tables for that, and you can use a same relation table, and you can actually match them and merge them. So to find this patient, whenever actually a doctor goes to the hospital, you kind of need to run this select statement here. So we have the patient information and we have the same relation. Our match is going from patient table to the patient table by using the same relation. And we are looking at the PID 1. Well, let's say this is maybe the MRN number we are looking. So in this case, this is going to find all the patients, the same patient, coming from the different sources. Next one was the social media. So in here, we are looking, I don't know if, I think Facebook or Instagram, one of them. So what do? We like things. So in here, there's a picture, or it can be a post, right? So you just need to click like here. And as soon as you click the like, you're going to create the relation. You are going to actually, know who the user is, and you know what they are looking for. This might be a picture ID, photo ID, shop ID, whatever. When you click the like, you're going to actually create that relation in that relation table. So to find the data, what we actually have to do here is we are going to go and look at the users table. We are going to go to the post tables, and we'll use the like relation. And we are looking this person. So this is going to give you all the posts liked by this person. Now, everything I show you so far is available in 2017. 2017 had, great, I guess, features for graph database tables, but it was missing a couple of important things. So those are actually fixed in 2019, or if you're using Azure SQL, they should be already there. The first, I guess, the missing part was, for example, if we have a product entity and user entity table. Well, usually the relation is going to be user is going to like the product. But in 2017, nothing is actually stopping you. A product can like user, which should be an invalid data. And you might want to kind of control where relation is coming from and going to. So to do that, in 2019 in Azure SQL, you can actually create edge constraints. They were pretty simple. We have the alter table is the same. We are adding a new constraint. We give a name, and we are saying that this connection can go from users to product. So if you're going to try to, go from product to users, you're not going to be able to create that data in SQL Server. So you can do that with one or multiple tables. So in here, I'm adding guests to product. Also, you can actually try to maybe control a little bit more if users will try to delete any of the user or product entities. In this case, what you are really saying here is if you're going to delete a user or product, you're going to actually delete all the records. So you are not going to have kind of data hanging out there and it's missing the relation, users, or product data. Or you can just simply say that that's not going to happen by just saying no action. SQL Server is going to actually throw an error, and you are not going to be able to delete anything. So you can do that with the edge constraint too. Now, just like any other tables in SQL Server, indexing is important for graph database tables. So if you look at it, we have the special columns, node ID, edge ID, from ID, and to ID. You are really not going to use them in your queries because you are going to use that match clause, but that doesn't mean that system is not using them either. So system actually uses them to find data, and you must actually create indexes on them if you don't want, I guess, table scans whenever you make a graph database tables. So for example, in here, we are having this query. We are finding the alike products. If I'm going to run this query as it is, without creating any indexes, what's going to actually happen here is, if you look at the execution plan, you are going to end up with a table scan, which means we are looking every row in that table, and there's no indexes. And graph database tables can get huge. So this is going to actually, cause delays, and people are not going to like to wait. So the table scan is not going to be good. We want to see, index 6 here. To do that, we have to actually create indexes, especially in the relation tables. I say because special relation tables, if you don't create the index on the node ID, actually SQL Server kind of creates it for you in the backend. So it kind of backs it up there. But for the relation tables, you have to create them manually. So in here, as you can see, I'm just creating a unique non-cluster index in relation table from an ID to ID, and same with the wished table. So if I'm going to run the same query here, then that table scan is going to be gone, and we are going to actually have index seek, and the things are going to work much faster.
Hasan, I have a question for you.
Sure.
So you mentioned that it would create the indexes automatically on the node tables, but not on the relationship or the relation tables?
Correct.
Why is that? I would think it should be automated as well.
I'm not sure the reason for that, but the node ID in here, let me go here. This one is getting, it creates a clustered index on it if you don't create it manually, but for whatever reason, it doesn't do it here.
Okay, and if you create it, then it overrides, or it doesn't create it on the back end.
For the edge tables?
For the node tables.
Yeah, so if you don't create it, it creates it for you.
But if you do create it, there's nothing that overrides it on the back end, is what I'm saying.
Yeah, it doesn't.
Okay.
But the most important one really is the edge tables, because they are the one which is going to have all kind of relations, and those are the place I guess they goes hop from the entity or entity. So the edge tables are the one which is connecting each other. So really the index is more important, I think, from ID and to ID. So I will really pay attention to that, because if something is slowed down, and if you see table scans, that means you are really missing an index here. And the next one, which is pretty complex one, I'm not gonna lie, is the shortest path. Shortest path came in 2019, and you use the shortest path function in actually match clause. As it suggests, the name suggested, it finds the shortest path between two entities. So the best example we can say, if we are going from this location to this location, there are many paths to reach there. But which one is the shortest way? So that's really what it does. It sounds simple, but writing the query can be challenge. So for that, we are going to use the graph path aggregation functions. We need to use the for paths. It's almost like an attribute that you kind of need to tag which tables actually you try to aggregate. And then you're going to use the match clause, and you're going to put the shortest path in the match clause. And also you're going to say arbitrary length, like how many times you want to actually hop to find this data, or you want to actually hop until the end of the table. So when you look at it like that, it took some time for me to understand it too. So I'm not really, it might take some time to understand. So if you look at actually a little bit more closer, we have the graph path aggregation functions. It can be any of those functions in here. And we are going to use the group graph path. That's always going to be here for any of the classes you are going to use. We are going to have node or edge tables we are going to use in this query. So the first table that you are starting is not going to have the for path, but the other tables are going to have the for path because those are the tables we are going to use the aggregation for. And we have the shortest path in the match, and we are passing the graph search pattern in the shortest path. And in here also, this is telling you like, are you going to repeat, how many times you're going to repeat to find this data? Or if you just keep it plus, that means you're going to run it until the table ends. So it might take a little bit time to actually find it. So let me actually start my demos here, so it might be much easier to understand it when you look at the demos. So let's actually open the SSMS here. So I'm going to start from the beginning, creating tables. So right now, as you can see, I am creating users table here. And by just saying as node, that's going to make it entity table. I have a products table with all kind of columns here. Again, I have the as node, which is going to make it entity table. You can create an index if you want. I'm not doing it in this way. I have a like product. That's going to be the relation table. And I'm creating an index on it with using the unique non-clustered index. Which table is going to be my relation table again, as you can see as edge, and I'm creating another index here. So let me run this first and have the structure ready. Everything is created, everybody's happy. Now we are going to insert some data. This is the products table. I'm putting all kind of products in it. As you can see, nothing is really different with the insert statement. And I'm putting some new users in them. And let's do this first and look at the tables. Now, if I go and look at the products table, you are going to see the node ID here. It's a JSON document, and everything else is here. So now we have to create some kind of relations between. So we have the alike product, which is going to show us which product is like which one. So I'm getting the node ID from products table. As you can see, one is like second one is the sixth one. So I'm creating this relations in here. Let's do that. Now we have a wish table. So wish table is going to actually have entities from users table and products table. So, which means that they don't really have to come from the same table. Entities can be different. So this is an example for that. So we are going to have some wish list between products and users tables and do that. Now, if you look at one of the relation tables we have, as you can see, a bunch of JSON documents here, really, by just looking at this is really not that useful without the match clause. So you can update only the credit date. So if I run that, you should be able to see that I can update it, but I cannot update anything else. Now, let's have some match queries here. So what I'm doing here is I'm finding let's say this is we are the e-commerce website, and we are gonna show what is like, which product is like which one. If I run that one, as you can see, I have let's say our user is looking the Kindle Fire 7, it's $49, and I have another product just like this one, so I can suggest that to my user in a place of the screen, which is a great option really without using any kind of AI or anything like that. You can use this dynamically and give user options and some suggestions. Now, what we are doing here is, so this is really simple. This can get complex. So in here, I'm making a little bit more complex. So I'm looking the user ID 1 here. So my match clause is going from users table to products table by using the wished relation. So this is giving me all the wish list of all the users. And direction is this way. So I'm going to products. In the meantime, I have another match clause here. And this is saying that the relation is actually the direction going this way. So this is going from products table to products table by using the alike product. So this is going to give me all the wish list of Anna, and also it's going to give me the alike products. So this looks like Anna wanted Fire HD 8, but in the meantime I have Fire 7, so I can kind of suggest that in the same time. She wanted iPad 3, I have iPad 2. So this can get really complex. You can kind of use it just in one clause like that, or if you want, this is going to actually give you the same exact the results. You can make it, I guess, more readable like that. So I'm just using the and here. So this should give me the same data. No, they don't like it here. All right, didn't like it. Let's see. All right, well, we'll be back to that. I'm not sure. All right, so next one is a little bit more complex. So I don't know if you have any experience with the Geo Spatial Data, but SQL Server handles that too. So what I'm going to do here is let's say we are a company just like an Amazon, and we have products. We have many warehouses in the company. We have many users. So those are going to be my entities. Also, we are going to create some relation table, which is in stock, is going to be between the products and warehouses. So if I have the product in a warehouse, I'm going to use the in stock relation table. And in process, I'm going to use it whenever a user actually buys a product and pays for it, then it's going to be in an in process. It's going to be between user and products entity. So I'm going to just keep that simple. I'm not going to have all kind of columns in it. So this is my product table. I'm going to make it an entity table. Warehouse, as you can see, is an entity table, but it has this geography data type. Well, warehouses, I know where exactly they are. So I can really know latitude and longitude of them, and I can just create that in here. I have the users table, is an entity table. As you can see, I have the geography here too, which means the location of the user. When I say location of the user, I'm not meaning that I know exactly where I guess, the address of the street number. I don't really care about that. As long as I know the city, I should be able to kind of estimate how long it's going to take or how much it's going to take for me to actually send the package to the user. So I don't really need to know exactly where they live. As long as I know the city here, I should be fine. And the latitude and longitude of cities should be free. We can get them anywhere on the internet. And so let's actually create all these tables first. That's the first step. I think we are going to use different one here. Let's try again. All right, the next we are creating the in-stock relation table, and then we are creating the in-process relation table, and I'm putting the indexes on them. Now we are ready to put some data in them. So this is my products here, as you can see. I'm just inserting them in my products table. I have my users, so the only thing you kind of need to look at here is this is how I am defining the geospatial data. This numbers here is the latitude and longitude of Kansas City, and I'm creating a geographic location for it. So that's gonna be my users table. Let's do that. Next is the warehouses. So warehouses the same. Those are my warehouses, and I know exactly where they are. So I know their latitude and longitude here. I'm putting them in my tables. Now I have all my tables. The next is gonna be more dynamic. So whenever a user, actually, this is the first one is in-stock. So this is gonna be the warehouses and having this product. So that's in-stock is gonna give me which warehouse has which product, which I should have some kind of system actually, I guess, populating that in my backend. So let's run that first. This is gonna create all the products in warehouses. This one is gonna be dynamic in process. So what's gonna actually happen is when the user goes in the page and buys something and we get the money, then we are gonna actually create this relation between the user and the product. So we can actually go and figure out, okay, we are gonna send this product to this user, but from where? Because we have many warehouses. If the user is in New York and we have a warehouse maybe in Los Angeles, we don't want to send it from Los Angeles if it's available, maybe in Ohio, right? We want to send it from Ohio, not from the California. So we're gonna try to solve that problem, but first let's actually have these relations. All right, now we have all the data we need. Now the hard part is how are we gonna know where are we gonna send these products, which warehouse we should use, which one has the shortest distance to the user. So we have a SubQuery and SubQuery here. I'm gonna run the SubQuery first. If you look at that, before I run it, as you can see, I am using st distance function. That is a geospatial function, and all it really does is it finds the shortest distance between 2 points. So really, this is gonna find all the distances between each warehouse which has the product and the user. I am dividing to this number because usually this is gonna return in meters. So I want to see in miles. That's why I am actually dividing the number. So let's actually run this first and look at the information. For example, we have a user ID, 5, George. He is buying a 27-inch monitor. And he is from Virginia Beach. And looks like we have this 27-inch monitor in 3 warehouses. And this is the result of the ST distance here. It tells you the distance between Virginia Beach and Minnesota. So 1200, 1551, and 2492. Now, we want to send it from here especially if you are offering free shipping, because this should be, I guess, cheaper to actually send it from Minnesota to Virginia Beach. Now, this is going to give you everything, or I don't want everything, I want the best one. So that's why I have this W priority, and I am using the window function here, rank over, which is going to give you these numbers by respecting the miles. So it's really sorting by that, as you can see, 1, 2, 3, and 1, 2, 3, 4. So this person is Mike, Las Vegas. It looks like this dining room set we have in 4 places. So as you can see, it goes 4, and after that it goes back to 1. If you look at the match class, we are starting from the users table, going to the products table by using the IMP, which is the in process. Those are the stuff that they bought, and those are the products I have in warehouses. And my main query here, I am looking the priority 1. So this is going to give me the shortest distance. So if I run that, rather than seeing everything, it's going to tell me exactly where I should send the 27-inch monitor to George, or the iPad to Tom. So you can see we make smart decision. Really, we didn't have to use any kind of AI or anything like that by using the the geospatial data type of SQL Server, which has been out there since 2008. And by adding the graph database tables, we found different ways to actually come up with, I guess, smarter ways to select data. You can select it like that, or what else you can do, you can actually use this for analyzing too. So when it comes to the SSIS, SSRS, you can use the graph database tables. So you can actually analyze the data, and maybe, for example, in here it says that this 27-inch monitor going from Virginia Beach to Minnesota is still 1,200 miles. Maybe we might need to make this 27-inch monitor available somewhere closer if you are selling a lot to this area. So you can use this in analyzing data too. All right, next. So whenever I kind of show this information, usually if you're a DBA, they say, well, okay, yeah, but you put like 230 rows in it. Of course, it's going to be fast. What about if you have 1 million? What's going to happen then? Many people kind of waiting, I guess, other people to use the graph database tables, and they don't want to, I guess, jump in the boat and figure out that this is not really fast compared to other tables. So I say, okay, what can I do? So right now you're in my personal computer. It's not really like a SQL Server machine, I guess, right? So what I did is I downloaded the Stack Overflow 2010 dataset. And by looking at it, I just created some entities and some relations tables. So I have a good amount of data here. Rather than just 10 or 20 rows, I have actually millions. So if you look at, for example, the tables, I have the users table. I put some of the columns here, and that's an entity table. And I'm not going to run those insert statements right now because they can run sometimes 10 to 20 minutes because there's just a lot of data there. And also I have the questions. That's an entity table. I have ask, which is going to be between the user and question. Whenever they ask a question, we're going to create a relation here. And as you can see, I say it took 4 minutes to actually run all this loop here. And then I have answers table. Answers table is going to have, I'm going to have an answered relation table. That's going to be between the questions and answers. So I'm going to writing another loop here to actually create all this relations. Now, when I'm done with this, I have this data. So if you look at the numbers, let's see, probably it's not going to run without this. First, let's connect. And now when I go back to the counts, let's look at that. I have 2017 and 2019, so I need to be sure that I'm connecting the right one for the right table. So that's why it's happening there. So right now, as you can see, I have more than 1 million questions, more than 2.5 million answers, and also I have more than 2.5 million answered relations and more than 1 million asked relations. So it's not 20 rows anymore. So let's actually try to find some data. I'm going to look here. Let's see what we are doing here. We are going users table to question table. We are looking really all the questions asked by this user, ID 1. If I run that, as you can see, I found 15 questions asked by Jeff Atwood. Those are the question IDs. These are the titles. As you can see, it didn't even take 1 second. So that's a good start. We can make that even more complex. So we are going to do the same thing here. We are finding all the questions asked by the user ID 1, but we are not really stopping out there. We are going to actually find the, I guess, all the answers answered to question ID 11 by other people. So if you run that, that's going to give you all the answers for the question ID 11. The same, Jeff Atwood asked it. Those are all the answers we got for question ID 11. As you can see, we are still less than 1 second. So that is, I guess, what happens if you have a large data set. Can you make this larger? Yeah. I guess I need more time to maybe put like 10 million or something. It's going to take some time, but inserting data is going to take some time because you have the relational database. You have to kind of start to, I guess, create the relations between the entities. So it takes a little bit of time to actually come up with the schema. But when it comes to query the data, it's pretty fast. Now, my last demo for you is going to be for the shortest path. Shortest path is the one came with the 2019, which is that kind of complex one. So what I'm doing here is I have a people table. Let's be sure actually we are connected to the right one first. Let's go to 2019. So we have a people table. That's an entity table and friend table. So really we are creating friendship between people here. So let's actually do that first. Let's run that. Okay. Now I have people in my tables. Now I'm going to create some kind of friendship between those people I am passing. So let's do that first. So I have my data in. Now I'm ready to run this shortest path. What I'm going to try to find here is I want to start from George, and I want to find how I can actually meet Lisa. How, like with all those people knowing each other, what is the shortest way I can actually reach to Lisa from George? So to understand that, first, we have two queries here again. One is the subquery. Let's run the subquery first here and see what we are actually having. This is going to give you all the possibilities between the people. So we are starting from George, and George knows Bob. George knows Bob. Bob knows Katie. So as you can see, last node is actually the aggregating functions. That's the last value. And it starts from the George, and you end up with Mike, Lisa, Linda, and Tim. Now, my shortest path, as you can see, this is really going from person to person. And I am using the FO, which is the friend relationship, and I'm looking the person ID 1. So that's why you end up with George here. And this one is just, I guess, to make this kind of string, I'm just putting this, the character here between each. That's why it's here. And as I said, for the first one is the regular table, regular graph table. I don't need the for path in it because I'm not doing any kind of aggregation on it. But I am doing for the second one and the third one. That's why I need the for path in them. Now, this one gives everybody. But I want to start from George and I want to go to Lisa. So if I run that, I'm just going to filter by person name and last node here. and that should give me the shortest path that I can actually go from George to Lisa. So to actually reach to Lisa, George has to kind of tell to Bob, Bob needs to go to Katie, Katie needs to go Mike, Mike needs to go Lisa. Now, how can we make this, I guess, see that actually it really works, right? So in this here, what I'm gonna do here is I'm gonna actually introduce more people. So let's actually insert data and run both of them. When I run that, as you can see, this data actually, what happened here is Bob met Ted, and actually Ted knows Lisa. So as you can see, before I actually push this data, the best way to actually reach Lisa was I had to go, to know all those people to reach Lisa. But because in here, actually, I introduced Bob to Ted, and Ted already knows Lisa, now the shortest path actually picks that change and shows you dynamically what is the shortest path going from George to Lisa. All right, I believe that's all demo I have for you. And thanks for coming to my session today. I hope everybody learned something new. If you have any questions, I will be more than happy to answer them. Thank you.
The recording of tonight's presentation will be posted on YouTube. I already shared the link in the chat window, but I will do it again for those that joined us late. Also, I invite you to subscribe to the channel. That way you'll get notifications whenever new videos are uploaded. And you'll notice that on the second bullet point is a link to my blog, samnasser.blogspot.com. And there I post technical events, which we'll be covering in just a little bit. And then last but not least, provide Hasan some feedback regarding the presentation. And again, the link for that will be posted in chat. And let me go ahead and grab that again. Manning Publication is providing a special offer for the user group, 35% off at manning.com using the discount code MTPCLEC21 ! And the link is provided there. And again, I will also share that within the chat window in just a second. In addition, I always like to cover upcoming events so you know what's happening in the area, as well as the virtual world. So on September 27th is the Akron AITP user group, and I will be presenting there an overview of cognitive services. The meeting will be held virtually, so you can join online free of charge. On October 5th is the Ohio North Database Training Group, and they're going to be meeting, I believe, in person on October 5th. On October 20th is the Hudson Software Craftsmanship Group that has been renamed to the Hudson Codecraft, and you can find meeting information posted on meetup.com. And they're meeting every third Wednesday, and in October, that will be October 20th. On October 21st is the Great Lakes Users Group, and last month we had one of the leaders, Joe Kunk, presenting to the group. And so they meet every third Thursday, so it doesn't conflict with our meetings. And again, they're free of charge, and they are virtual as well. And then on October 28th is the October meeting of the Cleveland C# VB.NET user group, i.e. this user group. And we're going to have Jeff Fritz presenting on .NET 6. And I encourage you to sign up if you haven't already done so. With regards to conferences, on October 16th is the Northern VA Code Camp, also known as the NOVA Code Camp. And that conference is free of charge. It's going to be on a Saturday, and it covers a variety of different topics related to .NET. On October 19th, this has just been planned, the Global AI Back Together. So the Global AI community is hosting various events, and we're going to be hosting one in Cleveland on October 19th. It's going to be from 5 to 9 p.m., and you can find meeting information at globalai.community. And again, all the links to all the events will be posted on my blog shortly right after this meeting. So I encourage you to subscribe. October 29th through the 31st is the Azure Community Conference held out of India. So despite the time difference, you can still join in virtually, and I believe that is also free of charge as well. Last but not least, November 8th through the 12th is the PASS Data Community Summit. Granted, this is a .NET user group, but obviously many of us work with data, so it's definitely a good event to attend and pick up some new bits of information. With regards to job openings, I know Tech Systems is always hiring. I'm not sure if we have a representative in the audience from Tech Systems tonight, but if there is, please feel free to speak up. If not, I always like to ask, who's hiring?
I know this is a C# group, but I know we all know front-end devs. My company, Chmura Economics and Analytics, is currently hiring for a junior front-end developer. So if anybody knows somebody who's looking to get started in their career, we're currently looking for someone who's on the newer side in front end. I'm gonna post the link to the job description in the chat.
Excellent, thank you, Amanda. Appreciate that. On the opposite side of the token, anyone who's looking. If you are looking for work and don't feel like speaking up or sharing it with a group, feel free to email me privately, and I'd be happy to share any job openings with you. As far as my contact information, you can always reach me via email, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser, and the blogspot, samnasser.blogspot.com. And lastly, I invite you to connect with me on LinkedIn. So if there's no questions or comments, I thank you all for attending and look forward to seeing you at next month's meeting.
Yeah, thank you, Sam. I would like to add one more thing. I'm just going to actually share one link with you. We just started an Azure Cosmos DB group. And if you are using it, if you're using it, please join us. It's going to be once a month. And we just met yesterday. That was the first one, but we should be there like every month. There should be somebody to, I guess, give a presentation.
That's excellent. So it's going to be every fourth Wednesday going forward?
I think it's the third Thursday. Yesterday was Wednesday. You are right. But it's going to be Wednesday or Thursday. We are still kind of, I guess, trying to schedule that, right? But yesterday was the first.
Okay, but either way, people can find information on the meetup site, which you posted in chat, correct?
Yep. Yeah, that's the user group.
Okay, and if you can't find the link, basically go to meetup.com and search for Azure Cosmos DB, and that is a global user group. So I imagine you're going to be meeting virtually all the time?
Yeah, once a month for sure. I think it's December.
Excellent. Very good. Well, thanks for sharing that, Hasan.
Yeah, no problem. Thank you.
And likewise, thank you for your time and thank you for your presentation. Well done as always. And look forward to seeing everyone at next month's meeting.
Thank you, everybody.
Okay.